The manufacture of methanol can be achieved in 2 stages. In the second stage, carbon monoxide, hydrogen and hydrogen react according to the following equation. 62.8 moles of, I'll go through that bit in a minute. Let's start with the expression that I can see here for Kp. So Kp is equal to partial pressure of CH3OH, that's the products, divided by partial pressure of CO times partial pressure of hydrogen squared. Okay, calculate a value for Kp. Right, so this is going to be a Rice calculation. So CO plus 2H2 is in equilibrium with CH3OH. The ratio is in the equation. The initial amounts, so I've got 62.8 of this, 146 of this, and none of this at the start. At equilibria, I'm told I have 26.2 of this, so the change here is plus 26.2. So the changes here will be minus 26.2 and minus 2 because of this times 26.2. So that gives me 36.6 and 93.6. So 1 mark for that. You can work out the total number of moles from this. So adding all of that together gives you 156.4. So from here, we need to work out the mole fraction. So 36.6 divided by 156.4, 93.6 divided by 156.4, and 26.2 divided by 156.4. Those are all the mole fractions. And then to get the partial pressures, I need to multiply by the total pressure, which is 9.5. So 9.5, 9.5, 9.5, and that gives me 2.22, 5.69, and 1.59. So putting this into my expression, 1.59 divided by 2.22 times 5.69 squared equals 0.022, and the units, so I've got 1 on the top, 3 on the bottom, so that's 2 on the bottom, so that's going to be megapascals to the minus 2. So for 4 marks, so there's 1, 2, 3 and 4. Part B, the experiment was repeated 3 times. In each experiment, the chemist makes 1 change but uses the same initial amounts. Complete the table to show the predicted effect of each change compared with the original statement. So let's start with Kp. So K is only affected, whether it's Kc, Kp, Kw, Ka, only affected by temperature, which means that these two here are going to be the same. So let's go back to the equation. So it is exothermic in that direction. So if I increase the temperature, it's going to go to the endothermic direction. So my reactants will decrease, which means that this will get smaller. Equilibrium amount. So, well, we've just said that this one is getting smaller. Catalyst doesn't do anything, so that's going to be the same. If I increase the pressure, so I've got 3 moles of gas on this side, 1 on that, so increasing the pressure is now going to move it in that direction, the side with fewer moles of gas, which means my products goes up, so my equilibrium mixture will be greater. And then the rates, so increase in temperature will give me a greater rate, pressure, greater rate, and catalyst, greater rate as well.